On to question 4. A group of 100 adults recorded the amount of time, T, they spent exercising um, each day. The results are summarized in the table below. So this is our summary. Okay, so a histogram is drawn to represent these data. Calculate the width. Okay, so this is a very simple question. What they're going to do is we're going to be using, they'll give us, for this particular question, I'm going to change it to ballpoint pen. I think it's better. So let's look at this one that they gave. So the interval where t is greater or less than 0 and less than 15, the width is 0.5. So this is the one we're looking for. Now, what is the difference between the two? 15. 15 minus 0 is 15. So they're saying that 15, for 15, the width is going to be 0.5 centimeters. So for the difference of like class interval, the difference is going to be 0.5 divided by 15. So the desired one is 60 to 120. So this guy over here, and we can see the difference between the two is going to be 60. So for a difference of 60 class interval, it's going to be 0.5, 15 times 60, right? As simple as that. 15 times 60, which gives us, well, 2. So the width is just going to be 2 centimeters. Now, what about the height? Now, we know that the frequency density is the height of a histogram. So what is the frequency density? Well, the frequency density is given by the formula frequency divided by your class width. So over here, we have the frequency of 25 and the difference of 15. So it's going to be 25 divided by 15, right? So all we're doing is just we're taking these and just using this formula over here. So it's going to be 5 by 3. So now they're saying, okay, so for a frequency density of 5 by 3, the height is 6 centimeters. So we're going to say for a frequency density of 5 by 3, the height is 6 centimeters. 6 centimeters. So a frequency density for 1 is going to be 6 times 3 by 5. So a frequency of our desired one, which is going to be 24 divided by 120 minus 60, 60. 24 divided by 60, which is 2 by 5. So for a frequency density of 2 by 5 is going to be 6 times 3 by 5 times 2 by 5. I'm not going to even attempt using my brain here. Just going to use the calculator as usual, 2 by 3, which gives us a height of, I think I made a little mistake here. Was it 6? 6 centimeters. So we have 25. Yep. So times 2 by 5, which is, got it. So our height comes to be, basically just say you divide 3 by 5 and then you multiply this by 2 by 5. And we get a height of 1.44 centimeters. That is our height. That is our, oops, and that is our width. Okay. Use linear interpolation to estimate the mean time spent. Okay, good. So over here, we're looking for interpolation. So you gotta find the cumulative frequency. This is always gonna be 25, and that's always gonna be 100. 25 plus 17 is 42. Plus 28 is 70. Plus 24 is 94. And there you go. Now, since it's median is half of your entries, right? So what we're going to do is half of our entries, which is 100, half of this is 50. And there's a formula for this, and I'll show the formula. But first we have to look, where does our cumulative frequency cross 50? Well, 25 is less than 50, 42 is less than 50, 70 is more than 50. So this is where our eyes should be in. Now, You have to look into the um excuse me. We have to look at the class interval, and we have to see if it's an open or closed data. This is a closed data. So we're going to look at the Q2. This is how the formula goes. Q2, take away the lower bound, divided by the upper bound minus the lower bound is equal to the thing we just got over here minus the previous data, previous cumulative frequency divided by our current frequency minus the previous 72 minus 42. 70 is actually 70. So we can find the Q2 directly. So I'm just going to put this in the calculator. 50 minus 42, 70 minus 42 times 60 minus 30 plus 30, which gives us a value of 38.5714 dot dot dot. So you can say 38.6 to 3SF. And this was A, right? There you go. Next, we're going to move on to C, estimate the means time spent by the adults. Now, the formula for mean is the mean is equal to f x squared by n. So fx, they gave us the whole thing over here. So let me put this in the calculator. 4555125.5 and 100. No, that's not actually the formula. Sorry, I got it wrong. That's a formula. Fx squared is where you find the standard deviation. We will need that in the next step. I'm sorry, guys. So all we have to do here now is we just have to multiply these. Your midpoint is that, so just multiply these. So we're gonna have 25 times 7.5, and then we're gonna have 17 times 22.5, 17, 22.5. I will not have space if I write this in such scale. And then we have 28 times 45. Then we have 24 times 90. 24 times 90. Then we have 6 times 180. All divided by 100. Put this in the calculator. 25 times 7.5. 17 times 22.5. 28 times 45. 24 times 90. 6 times 180. And divided by 100. This gives us 50.7 as our answer. Moving on to part D. Standard deviation. Yes, that's where we need that. So standard deviation is a formula where fx squared divided by n minus your mean squared. So we can say, what was it again? 4.4. We have been given this value. The exam is kind. There are 3 5s, 3 5s, 1, 2.5 divided by 100 minus our mean that we got from part C, and then you root square that. So 4, 3 5s, 12.5 and 100 minus, and we get a value of 44.5492 dot dot dot. So we can say the standard deviation is 44.6. Is it? No, not 6. That's 4, so it's just going to be 5 to 3 SF. We're doing good so far. Let's keep going. E, describe giving a reason the skewness of these data. Now, we're going to be looking for the median, and we're going to be looking at the mean. Okay? We're going to look at the median, and we're going to look at the mean. So, our mean is 50.7. Our mean is 50.7. And the Q2 that we got is 38.6. So mean and median. Since our mean is greater than our median, the skewness is positive. The skewness is positive. Skewness is positive. If it was the other way around, the skewness would be negative. If it was equal, it would be symmetrical. Simple as that. F. EF. State giving a reason. Oh, further analysis of above should reveal that 18 of the adults took no exercise each day. 18 of the adults took no exercise. 25 adults. So 25. So among these 25, 18, so 7. So the 7 here is extra, right? So estimate the median. Now, the median won't change because this is below the median, or I should say the 18 values or the changes that happen are below the median. Had it happened like above the median, then the median would have changed. So that's not going to change. Will the mean change? Well, yes, the mean will change and it's going to be smaller because now in reality we took 25 into our register, assuming that all 25 did exercise, and turns out 7 actually does the exercise. So 7 is going to be our actual value that we should put into our entry. So now our mean is going to go low. So our mean, let's write it over here. So first we should say, what was the first one? The median. So median doesn't change. Median stays the same as the changes are below median. The mean is going to decrease. Mean decreases as now only 7, or we should say 7 times 7.5, because that is the fx 7 times 7.5 are taken into account, not the previous. What was the total? 25 times 7.5. And what was the last thing they asked? Standard deviation, perhaps. Yep, standard deviation. Now, standard deviation, I have to think about this. Standard deviation is how far something is from the mean. So since now the mean is smaller, the standard deviation would be larger. Because now the remaining 18 are going to be like 0. So now the zeros count, and now the data is more spread out. So standard deviation is going to increase. Standard deviation increases as data is more spread out. Since the mean is now small and 18 of them are going to be null, so they're going to be those are going to add on, and that's going to increase the range of our data, making the standard deviation greater. Variance is how scattered something is. Standard deviation is how far it is. Again, it's kind of like similar. Standard deviation is basically how spread out the data is, right? And yeah, so hopefully we got it right. Yeah, that concludes this question 4, which was about histograms, I believe. Histograms, yep.